Well, hello, and a very good day to everyone. Today, I will be explaining about the things that we find very common in our life family pedigree. So, what is family pedigree? So, I'll be explaining it right now. Family pedigree, right, is something that we will be referring in a chart or a flow chart, or most commonly known as a family tree that tracks the absence or presence of a trait through generations. So that this, right, it can help to determine whether it is a dominant, recessive, autosomal, or sex link. So, in a shorter way, right, in an easier way, I will say that family pedigree, right, is something that is a more to a family tree. Yes, correct. It's more to a family tree, but it's not just only to show who it is, like who is your forefathers, who are your uncles, who are your aunties, all that stuff, right? But it's more certain to show its characteristics or disease that are passed down to generations. So, what is the disease now? So the diseases that are passed through in these generations are most commonly known as hemophilia. Oh my god, what is hemophilia now? Hemophilia, if you look clearly or if you heard before in this video, or will be one of my friends speaking about hemophilia, right? So, again, hemophilia is a genetic disorder that affects the blood ability to clot, which means, right, the person who is affected by hemophilia, right, they does not have the ability to cover or to clot or to cover, like, to make it easier, to cover their blood efficiently. They are not able to manage their blood to cover to clot it. So, in short, right, people with hemophilic or people with hemophilia will bleed for a longer time. Why? Because since they have the inability to not blood clot in a shorter period of time. So this disorder, right, is more common in males or more commonly found in males than females. Why? Yeah, this is now the interesting part. So why this disease is more common to male but not to female is that because male has XY chromosome and woman has or female has XX chromosome. See, small difference but make a big change. So why it is more affected to males is because that male has XY chromosome. Since hemophilic, right, it's more to a X genetic disorder, which means, right, since male have only one X chromosome, and for sure if X has the hemophilia gene, they will certainly have the disorder. But then female also same thing, but since they have the two chromosome, XX chromosome, but then we assume that X is the hemophilia gene, they usually won't get the disease, but they can pass it down. So that's why we call as a carrier, which means, right, they certainly not affected by the disease, but they have the ability to transfer that kind of disease to another person, like to their children, or yeah, right, the family progressions. So so that is for hemophilia. So if you look at the pedigree chart or the family pedigree chart that have been created in this slide, right? So what is that? Yeah, if you see there are so many boxes, so many circles, right? Yeah, you feel like very confusing. Don't worry, I explain it to you in a shorter and a simple way. So you see that there are many squares, there are circles, there are shaded circles, unshaded circles, there are squares as well, there are half shaded, half non-shaded. Okay, don't worry. So the one who are shaded for the squares are unshaded circles and unshaded squares, right? They are referred to a normal male and a normal female, while the one who is shaded, the shaded squares and the shaded circles, right, they are referred to a male and female that has hemophilic. While the one has a semicircle or a semi-shaded region, it is more, I refer to a female carrier. Like I told you just now, they are not affected, but they transmit the disease to another person. So this is where Roman numeral came from. So where does the Roman numeral? So yeah, the first Roman numeral, you see the forefathers, the first forefathers, you see at the top one, we just assume that the top one is our first forefathers. Okay, if you see the first Roman numeral, right? So I'll just give you a situation, an example, just like in the flowchart. Okay, when a person is got to marry or being married, or suddenly they just married the person who has the hemophilic or female hemophilic, right? They certainly for sure they have a children that is affected by hemophilic. But who it is again? Like I told you just now, the person who are infected are mostly by males, right? So mostly the male children are affected. That's why if you see in the Roman number 2, right, the male person, you see the square shaded, are referred to a male that has a hemophilic. So they are certainly affected by hemophilic. But then why the woman or the female does not affected by hemophilic? It because you see the Roman number 2, right? They are not affected, but they are function as a carrier, which means they have the potential to transmit the disease to the children also. Understand, right? Which means they have a high chances that their children have hemophilic too. So now that is the one situation. Now we have two situations right now. So the first situation in Roman number 2, Roman numeral number 2, right? So what if a normal male is getting married to a person that has a female carrier of hemophilia? So what will happen then? So the chances are more to like a 50-50. You understand that 50-50? There are chances you might get hemophilic or you might not get hemophilic. So obviously female won't be affected, right? Since they have a XX chromosome. So we leave that. That's easy one. But now you see the male. The male, one of the children or one of the siblings affected by hemophilic, but other one not affected. Why? So again, I tell you that is a 50-50 chance. So in some situations, both can be affected by hemophilia. At some situations also, only one people are affected by hemophilia, while the other one or the other male will not get affected by hemophilia. So that is the first situation. So if you go to the second situation, right? What if the hemophilic male and the hemophilic female got married to each other? This is more common or more easy to understand. So obviously, when you're married to a person that has hemophilic, when you itself have hemophilic, right? So obviously, the children that have been born to us, they have hemophilic, right? So yeah, you see, the male and the female both itself have hemophilic. Then why suddenly, you might be thinking, right? Why suddenly they have female got affected by hemophilia? Again, they have XX chromosome, correct? You say functions carrier. You say female are more to a female carrier. Yes, correct. But now, if you see closely, women have XX chromosome. We assume that it has been one of the gene X has been destroyed. But now if you see closely, there are two people affected by the hemophilic disease, which means there are two gene X. So certainly, right, women are not only get affected by one chromosome, but also they got affected by two chromosomes, right? So that's why certainly their siblings or their children are got affected by this hemophilic disease. So yeah, it's very easy, right? If you don't really understand, right, just rewind this video so that just take a look. You can pause this video, just take a look, try to get a picture of it, right? So you can understand it more clearly. Okay, yeah. So I think that's all.